Okay, so good afternoon, everyone. Welcome to the second technical session of day one of this workshop on computational physics using Python. So let me start by presenting my screen. So many of the participants are there yet to join, but nevertheless we can start. Just let me know, Amma, if my screen is visible.
Yes, it is loading now.
Okay.
Yeah, it is visible now.
All right. So we in the morning session we had looked at some of the we were introduced to the Jupyter notebook. Now what you're going to do is I'm going to introduce you all to some basics of Python, because I'm sure that most of the participants here they have absolutely no idea about how to work with Python. In fact, I'm sure that a few of the participants would have had no experience in coding also earlier. So I will start right from the basics. Okay. So this is the notebook that I have created. Like I had told in the morning, this entire workshop will be conducted completely using Jupyter notebook. Okay. So the elements of Python. Okay. So first thing that we need to know when we're talking about Python, you need to know about variables, because you see we are manipulating data, we are manipulating numbers, and these numbers are stored in memory locations. And if you want to access those numbers from those memory locations, you have to give some names to them. Now, these names are either you could call it as a variable because the value could change, or it is also sometimes known as an identifier. Okay. So once we have a variable or an identifier which which refers to some memory location, then some values can be assigned to it. So this is what I mean by variable assignment. Okay. So we create a variable and we assign some value to that variable. So that's what variable assignment is. Okay, so now variable names, we have to follow some rules regarding the names of the variables. The names of the variables, it may contain letters, it may contain numbers, letters either in small letters or capital letters. It may contain numbers, and it may contain the underscore symbol only. These are the only things that a variable name can contain. A variable cannot contain spaces. Okay, that's not possible. Okay. Similarly, a variable cannot start with a number. So a variable can start with either letters, small letter or capital letter, or underscore. Variable cannot start with a number, even though the name of the variable can contain a number, but it cannot start with a number. And variable names are case sensitive, which means small letters and capital letters, it makes a difference. So for instance, I could create a variable called as x. Okay, and I give it a value 1. Okay, this is allowed. Okay, so I could just compile this, and it has compiled nicely. Now let me create a cell. This is one cell. I want to, how did I run this cell? Okay, there are 3 ways by which you can run a cell. You could click on this one, run. Okay, you could click on this, it is going to run that cell, and it will go to the next cell. Next, another way to do that is you could press Control and Enter. When you press Control and Enter, it will run that cell and it will stay in the same cell. Okay, so that's the keyboard shortcut. Another way to do that is you can press Shift and Enter. That will run the cell and it will move on to the next cell. Okay, so these are the ways by which I can run. Now, how do I add cells? You could add cells this way. Let's say by Control Enter. This is what I usually do because it's easier to work directly from the keyboard. If I press Control and Enter, it runs this and it stays on the same cell. Okay, you can see here the cell, it gets color coded. It has become blue. Okay, blue means you're not editing the cell. Okay, now I can edit it. Now when the cell becomes green, when the cell this band, when it becomes green, that means you can now edit the cell. Okay, when I run this Control and Enter, it has now become blue in color. That means I cannot edit it right now. Okay, similarly here also, this cell right now it's blue. That means I'm not editing it. But if you want to edit it, you can either press Enter. Okay, now it has become green. That means now you can edit the cell, or you can just do a double click, like just either you can press Enter, or you can just go here and double click on this. That is going to make it this one. So now you can, when you click on this is going to become green. So that means now you can edit this. Okay, so this is what it means. The cell, the side band, the color, that indicates what is the status of that cell. So right now it's blue. So similarly, when I click on this one, now it's blue. That means I'm not editing it. Okay, so click on this, it becomes green. run this, that's fine. Now, when the cell is blue in color, then you can add cells below. You can add cells below, or you can add cells above using this shortcut, which is mentioned here. Insert cell above A, or below, if you want to put below, then B. But you can do that only if the cell is blue in color. Okay. So if you want to add a cell, just press A from the keyboard. Okay. Above this, there is going to be a cell. If you want to add a cell below, press B. Okay, that's going to do the same thing. So now, like I said here, variables are case sensitive. So I could use, instead of small x, I could use capital X. Okay, it's not so clear here. Let's say capital R. Capital R is 0.1. Okay, so this is a valid variable name. Okay. Now, if I insert in this one, if I make small r, this will also work. They are not the same. Okay, these two variables are different variables because variable names are case sensitive. Okay, variable names, they can contain letters, numbers, and underscore. So this is a valid variable. So test, okay, underscore 01 equals 55. Okay, this is a valid variable. Okay, but this is not a valid variable. This is also a valid variable. So underscore 01 underscore test equals 96. This is also allowed because it starts with an underscore. Okay, but this one is not allowed. 1 underscore test equals 78. Now if I run this, it is going to give me an error. It tells you that, you know, it starts from a number. It is not allowed. Okay, so this, you cannot name your variables like this. So these are allowed variables. Small letter, capital letter, they are allowed. Underscore, numbers, all of these you can use. It can start with an underscore, or it can start with a letter, but it cannot start a variable name. It cannot start with a number. So that is not allowed. Okay, so these are some rules that you'll have to follow for variable assignment. And usually we need to put some names which is meaningful. Okay, always try to put names which are meaningful. Okay. So now we can also display the contents of a variable. How do I do that? How do I display the contents of a variable? You could do that using the print function. I'll do that little bit more in detail after some time. So let us say we have, let's say, x equals 1. Okay. Now I want to print the value of x. So I could do something like this, print x. I could do that. Okay. Now when I run this, you can see here it has printed 1. Now I could also modify the print command. Okay. So before this, I could put a string, comma, and inside this, I could write something like this. The value is, and if I run this, then it is going to display it accordingly. The value is, till here it will show, this part it will display, and after that there is a comma, and then there is a variable x. Whatever is the value of this variable x, it is going to next display it over here. So you can use the print command to display output like this. Okay. Now this Python has got one way. There's one more way of variable assignment in Python, which actually makes Python much cooler than other programming languages, like for example C or C++, and that is you can have multiple variable assignments. Okay, there's something called as multiple variable assignments. Let me add this over here. This is called as multiple variable assignment. In the same statement, you can actually assign multiple variables. So I could have a scenario like this: a comma b equals 7 comma 8.6. Okay. Now if I do print a and print b, okay, it's going to print a and b. So what it does is, by separating commas, okay, using commas I could separate. So it means this is one variable. This variable a will be assigned this value on the right hand side. On the right hand side of this equality operator, the first value will be assigned to a. Okay, first value before comma, and the next value after comma will be assigned to b in the same order. So I could also have, you know, multiple values. I could have one more value, c equals, let's say, I could do that also. Okay, you could have multiple. So you could have like 50, 60, 100 variables. You could assign all of these variables within the same line itself. Okay, this is not possible in C or C++. There, every variable that you want to assign some value, you have to do it in the same line. Okay. So now this also, because of this feature, multiple variable assignment, this feature actually gives us some remarkable thing, a very easy way of doing something, and that is swapping values. So if I have something like this, let's say PQ equals let's say 4 and 8, 4 and 9. Let's say PQ is equal to 4 and 9. Okay. Now let's say I do print P comma Q. Run this, it's showing 4 and 9, right? Now if I do something like this, P comma Q is equal to Q comma P, and then if I do print P comma Q, what this is going to do is it's going to swap the values. Okay. So what it is understanding is, Python understands this as, on the right hand side, whatever was the value of Q, you put it in P, whatever was the value of P, you put it in Q. So you are basically swapping the values. This is also something that you cannot do in any other programming language. If let's say in C, what you have to do in C, for example, what you have to do is you have to do something like this. You have to create a temporary variable. That temporary variable will contain P. Then you give the value of P, to the value of P, you give the value of Q. And then to Q, you give the value of temp. Okay, so 3 lines, you require 3 lines. In C or C++, you require 3 lines. In Python, you can do that in just 1 line. Okay, so this is how you can swap numbers. Okay, swap values of 2 variables. Swapping values of variables. By the way, what is this? This is known as a comment. Okay, this is known as a comment. We put a hash inside the Python. This hash is not the same as this hash. Okay, this is in the markdown. This hash is in the markdown. It's in markdown. This tells you that this is a heading. But when the cell is of type code, here the cell is of type code. So when the cell is of type code, then the hash means this comes from this Python programming language. This hash means it's a comment. Hashes are comments. Okay, so you can actually add comments here just to make things easy to understand. So here I do this line, P comma Q is equal to Q comma P. Okay, I see this line. Now let's say I'm reading this line, like somebody else is reading this line. So that person does not know, let's say, does not understand Python. So that person will not understand what is actually happening here. So what I do is I just put a comment here. This comment will tell the person that actually we are trying to swap the values of the variables. Okay, so that's what it does over here. So you can add comments, and comments, they make the code much more readable. Okay, if I run this, I think again it will become 4 and 9 because I ran this, it swapped again, right? So okay, so that's about how you can and then, yeah, of course, like I said here, multiple variable assignment. All of these need not be of the same type. As you can see here, A is integer, B is a floating type, and C is a string. Okay, so variables, they can be assigned different values when you're doing multiple variable assignment. Now, for physics, the variables that we usually use, the variable types that we mainly use in physics for physical computations, they could be integer types. Integer types are just pure numbers. Okay, without any fractional part. They could be float, with that means they have some fractional part. Fractional part means you could represent this in exponential notation also, or scientific notation, or they could be complex numbers. So we basically use these 3 types, these 3 variable types in physics computations. Okay, now why do we need these different variable types? Many reasons are there. First of all, the memory required for the program to run, okay, you can reduce that by using different kinds of variables. Then once the memory required is less, then the computation time also decreases. Then you could also remove a lot of semantic errors. Suppose, because there are for storing these numbers, lots of approximations are used for storing these numbers inside a computer in the memory location. Some approximations are basically used because ultimately it has to be stored in a binary format. So when you're converting from decimal system to binary system, then again there are going to be some losses in the precision. So these losses will cause some errors. So these errors, semantic errors, which are due to the approximation, okay, they get reduced when we use these different variable types. And lastly, they improve the efficiency of the program. Okay, then we could also have complex numbers. We can in Python it allows us to create and use complex numbers. You can create complex numbers in this way. So I could say that a, okay, z, okay, is equal to 2 plus 3i. Let's say I want to write 2 plus 3i. Okay, for I is the imaginary unit. Here in Python, j, if you use j is considered to be as the imaginary unit. Okay, let me put a comment here. J is the imaginary unit. Okay, so now you could print this also. Print a, sorry, oh sorry, my mistake. We're printing a here. I want to print z. Print z. Okay, so it's going to print it like this. Okay, so now you can, how do I access the real part and the imaginary part? We can do that there also. So I could print the real part using z dot real. Okay, that's going to print the real part, and I could print the imaginary part simply by using z dot imag. That's going to print the imaginary part. Here, I mean, I'm not putting anything. I do not use the print, but you could use the print command also. Print z dot real. Okay, it's going to give me this one. So if you don't give print, if you just give the variable, no, it will just show you what is contained in that variable, and it will show here out. I mean, it's going to be in red. This means that I have not used any print command. It is just showing me the value of this variable. Okay, so you can use z dot real and dot imag, these two objects to find out what is the real part and what is the imaginary part. Okay, so you could also round off a floating point number. Suppose I have a floating point number, you could actually round this off to whatever number of decimal points that you want. So for instance, let's say b is equal to 2 point. Okay, so we have some big number over here. So now if I say print b, okay, it's going to give me this, but I could always round this off. Okay, so round b, how many decimal places? Let's say I want to round this off to 3 decimal places. Okay, so let me just print this out now. Print b. Okay, sorry, I have to print round b. That's what I have to do. Print round of b. That is going to round it off to 3 decimal places. So rounding off, you can do that using the round function. This is the built-in function. Okay, round is a built-in function, or rather I could write this over here. Rounding of a floating point number using the built-in function, which we call as round. Okay, now you can see, right? You're able to see Jupyter Notebook in action. I'm doing the coding as well as I'm writing my text also, everything. Okay, I'm doing the coding as well as writing my text. Now suppose when I'm trying to share this with you all, how will it look like? I can just create a PDF file, and that PDF file will contain the text, it will contain the code, and it will also contain the output. Okay, now let's say I want to find out the exact value. Okay, this is one interesting thing. Suppose I want to find out the exact value of the floating point number, because like I said, inside the computer there could be lots of approximations which I use. So ultimately how it is stored in memory, that need not be the same as what you have given. Okay, so how do I show what is the exact value that is stored? Okay, so let's say the way to do that is I have to import the decimal. Understand what this means? Then we do decimal b. Okay, so this is the number that I have provided. This is the number that actually I had provided here. This is the number that I had provided, but inside the computer, in the memory, this is how it is actually stored. Okay, this is how it is actually stored, because the storage is not perfect. Okay, storage of values, the floating point values, is not perfect. It's not going to give you exactly what you have provided. Okay, there is going to be approximation. So inside it is, this is how it is being stored. Next, suppose I want to find out, suppose I don't know a data type, okay, because as you can see here in these, this one, all of these examples, I did not specify what is this data type, R. I just said R. I did not say, I did not tell Python whether it's integer or floating or character, nothing I have told. I just said R. It understands from the type of value that we have given on the right hand side. Here, there is a decimal point, so this is stored as a floating point type. Here on the right hand side, it is as an integer, so it will be stored as an integer type. Okay, so that's how you can actually, that's how Python actually determines what will be the data type of the variable. But then let's say I want to find out, okay, let's say I want to find out what is the data type, okay, what is the data type of a certain variable. Let's say I want to find that. Then you can do that using the, there is a function using, there's a built-in function. This built-in function is called as type. Using the built-in function, that built-in function, the name of that function is type. Okay, so how we can use this function is like this. So let's say I declare variables. Okay, p is equal to 5, and let's say q is equal to 6.0. Okay, let's keep it as 5.0. Then let's say r is equal to, let's say p, and s is equal to 3.1 minus 4.6 j. Okay, so this is what we have. These are the variables. Now I want to find out what is the type. Okay, so I could just say print, okay, type of p. Okay, what is the data type of p? It will show me that it's a type, integer type, class int. Okay, it is telling me this is basically integer type. Okay, so I could to make my output, okay, then over q it's this. Okay, it's giving me this, but for me to be able to understand the output, I could actually make it more readable by just putting some string here which puts some context to it. So I could say data type for p is, data type for p, okay, data type for p is int. Okay, so now it's understandable. Let me copy this bit. Like I said, it gives some context, okay, to this. This is data type for q. Let me copy the rest. Data type for r, and finally data type for s. Okay, so p is stored as an integer. You see, just by looking at the value on the right hand side, it's 5 without any decimal point. It is stored as an integer. Then q is stored as a floating type. Q is stored as a floating type because there is a 5.0. In fact, I think if we just put 5 point, that is also enough. If you just put 5 point, no need to put the 0, that is also enough. Okay, let me just try it once. Yes, it works. You don't have to put a 0, just put a 5 and put followed by a dot. It is enough for Python to identify that q is a floating type. Okay, then yeah.
Parag? Yeah, just to make a clarification for the students, this r is equal to p within inverted comma is not the p is equal to 5. Okay, it could have been.
Yes, good. Let me just put something else then. Something w. Okay. This is a string. This is not the same. I mean, here by mistake, like I had put p here. This p is not the same as this p. This p is the name of the variable. This is a character. Is just a string. It's just a character. Okay. So I could just put w here. Okay. Same thing. So this is basically a string. So I could, instead of using single quotes, I could use double quotations also. It does not make a difference. Okay. So Python does not distinguish between single quotes and double quotes. Okay, so this is a string type. Str means string type, and then s, again, it contains 3i minus, and it contains in this format it is written, that automatically understands that this is a complex variable that we are talking about. Okay, so that's how you can determine the data type of a variable. Okay, so using a built-in function. Next is interesting, concatenation of strings. Concatenate means to join. Okay, if I want to join lots of strings. Okay, so let's do something like this. Let's say I have a lot of strings. Let's say text1 is equal to workshop, then text2 is equal to on, text 3 is equal to computational, and text 4 is equal to physics. Okay, so I have created 4 strings. Okay, text 1, text 2, text 3, text 4. So these 4 strings, they will store these values. So now let's say I want to join all of them. Okay, let's say I want to join. Okay, I'll just add one more here. Text 5. Text 5. Let's say call it as 2020. Oops. Text 5 is 2020. Now 2020, this is not a number. Okay, this is not a number. This is also a string because it is enclosed in double quotations or single quotation. This is basically a string. Okay, so this is what we have. So now just watch this. If I just say print any one of this text, let's say text 3. Okay, it is going to give me whatever is the string that is stored inside this variable called as text 3. Now I could also do like this. I could join these variables in this way. So let's say text underscore 1 plus text underscore 2 plus text underscore 3 plus text underscore 4 text underscore 5. Okay, you can use the plus operator. You can use the plus operator to actually, oops, I think, just give me a second. Okay, by mistake I had pressed the insert button, so I did not realize that. Text 2 plus, just to clarify, I'm just putting some space. If you don't put space also, no problem, it will still work. So what I'm doing is I'm just adding these 4. Okay, text 1, text 2, text 3, text 4. I'm just adding them. Text 1 plus text 2 plus text 3 plus text 4 plus text 5. Here the plus sign does not mean adding numbers. Here the plus sign, just by looking at the context here. The context is both sides there are strings. So what it will do is it'll just join those strings and will create a new string. So this is what is going to happen. Okay, but now you can see here it has just joined everything together. There are no spaces. There are no spaces. So it just becomes one single word. Right? So what do you want to do if you want to put spaces? One solution is you could just put a space here. Okay, this is one solution. Another solution is the same thing. Instead of plus, you replace that plus with a comma. Instead of plus, you just replace it with comma. That is going to put an extra space here. Okay, so this is what it's going to do. So let me just note down here. I'll put a comment here. This is without spaces and this is with spaces. Okay, you could also find out the length of a string. Okay, you could also find out the length of a string. Print, okay, let's say length of one of these strings, text 3, computational. This is a big word. Okay, I want to find out what is the length of this. That means how many characters are there. Okay, text length of comma text underscore 3 is, okay, another comma. Then I can use this inbuilt function called as len. This inbuilt function will just give me the length. Okay, text underscore 3. Okay, so it tells me that there are 13 characters. There are 13 characters inside this text 3, which basically contains this word computational. So in computational there are 13 characters. Okay, so you can, these are some basic operations that you can do on strings. More about strings a little bit later when I introduce you to data structures. Now next is displaying output. Okay, displaying output. You can display output. We have been using this print function. But now we'll do this a little bit more in detail. Print function. A print function is used for displaying. Okay, whatever you put as the arguments for the print, it will just display. It always displays the current value of a variable. So let's say if I have x equals, let's say 6, okay, and I do print x, and then let's say I decide, let me run this once. Now let's say I decide to change the value of x. Let's say x, I make it 7. Now if I print x, okay, even though this command and this command are the same, but the result will be next time it will print 7. So it always prints the current value, the present value of the variable. Then you could display more than one value on the same line. So let's say x equals 4.5 and y equals, let's say 3.8. You could always say print, if I say x comma y, it's going to display both x and y. The values x and y it will display on the same line. Okay. You could also, it could be anything x, y, it could be any type. It could be integer type, float type, complex type, any type you can. Okay. Now formatted output, this is what we have done over here. Okay. You can improve the readability. Okay. You can improve the readability of your output by combining values with strings. Okay. So let's say something like this. Okay. So I could do something like this, print, okay, the value. If I just say print x, okay, if I just say print x, it will just give me 4.5. But what is this 4.5? I really don't know. So I could actually improve the readability of this. Okay, so I could do it this way. Print the value of x is, print the value of x is x. Okay, and let's say I want to print the value of y also. And the value of y is comma y. If I do that, the value of x is 4.5, it is showing 4.5, and the value of y is 3.8. So you could do that. Okay, so these kind of formatted output, it improves the readability. It improves the readability of your code. Improves the readability of your output. It makes more sense. A human reader who is reading your output, it will make more sense to that reader. Okay. Now, let's say I want to separate the values by some character. I could do that. The same thing in the print. So let's say I want to say print, I want to print x and y. Let's say I want to print x and y. Normally, if I do that, it's like this. But now, if I want to separate them, there should be a separation between the two. I could do that using the sep keyword, SEP, sep, the keyword. So just put the character which you want them to separate it with. So if I put a hash here, then it will put a hash here. Okay. So if I put a dollar here, okay, it will put a substituted dollar between them. Okay. If I put ampersand, it will put an ampersand here. Okay. So this is how you can separate them using some other character. Okay. Just put this. You could put something else also. So you can put, KKK and so on. Okay, so it's going to replace that. So the sep keyword, you just put whatever value you want. Okay, so that's how you can separate values using some character. Okay, now let's say, now yeah, this is important. Okay, floating formatting output with floating point numbers. You see the floating point numbers. They have thing is they could be stored to a very high precision in the computer, because if you're using 8 bits, like if you're using 64-bit representation, so that is going to give us a very large precision. So you don't want to keep on displaying such large numbers. Okay, so as an example, let's say I say that p is equal to, let's say, 22 divided by 7. Okay, p is equal to 22 divided by 7. So now if I do print p, okay, I get this number. Okay, so lots of decimal places, right? Lots of decimal places. So I don't want these many decimal places. Okay, I don't want these many decimal places. So instead of that, what I do is I could actually have a formatted output. Okay, how to put a formatted output? It's like this. You can use a formatting string. Let me write this here. Formatted output using formatting strings. Okay, these are C style. These are taken from the C programming language. This style of formatting strings, it is taken from the C programming language. Very handy. So what you need to do is basically this. I want to display P, but I want to display only up to the first 3 decimal places. I want to display only 3.142. Okay, I want to display only the first 3 decimal places only 3.142. First 3 decimal places I want to display. So if I want to display only the first 3 decimal places, how do I do that? You can use a formatted string. So this is how you use a formatted string. You put single quotes, then you put a percentage sign, and after the percentage sign, you have to tell, okay, how many, what is the size of the, you have to specify the size of the output and how many decimal places. So I want 3 decimal places. That means I want these, right? So how many significant figures do we have here? You can see here there are 4 significant figures, 1 figure before the decimal point and 3 figures after the decimal point. So there are 4 significant figures. Okay, so number of significant figures is 4. So I'll just give a general formula using the formatting string, that is C style formatting string, like this. Inside this we will have percentage, then you have number of significant figures plus 1. I'll tell you why plus 1, dot with how many decimal places do you need, okay, fine. After that, what you put another percentage sign, and then outside you put the variable name. Okay, so this is how you do the formatting. So here I want 3 decimal places. 3 decimal places means there are 4 significant figures. 4 plus 1 is 5. 4 plus 1 is 5. Why plus 1? Because you are basically giving what is the total width of the output. There is also the decimal point. Decimal point is also a character. So 4 significant figures plus one more character for the decimal point. So that's why we have to put a 5 here. So significant figures plus 1, 5, dot how many decimal places? We want 3. So you write it as 5.3. And of course, I think I forgot here. And then we have to put a F here to say that it's a floating point type. Okay, 5.3, then F, and outside this you put a percentage and the name of the variable. Okay, so now you see it has displayed till 3 decimal places, along with by rounding it off. Okay, it has rounded off and has displayed only till 3 decimal places. Okay, so you could actually combine such things. Okay, you could actually combine such things with other strings. So let me create one more variable. So Q, let's say Q is equal to 1.4143876 and so on. Okay, so let's say we have this number Q. Okay, if I just say print Q, this is going to show me the entire thing. But now I want to print, I want a formatted output. Okay, I want, let's say, instead of 3 decimal places for Q, I want only 2 decimal places. Okay, so you could have, for Q, I want 2 decimal places. So we just follow this format. Okay, single quotes or double quotes, anything will work. Okay, percentage, how many decimal places? We want only 2 decimal places. For Q, I want only 2 decimal places. 2 decimal places means 3 significant figures. So 3 plus 1, 4, dot 2 decimal places, F, and then outside we will have percentage Q. So that gives me only till 2 decimal places. Now, of course, you could combine these with strings also. So you can say like something like this. The value of X is, I just take the formatted, sorry, the value of P, not X. The value of P is, I just take this formatted string from here, paste it here, and the value of Q is, comma, take the formatted string for Q here, and simply paste it here. So this is going to give me in a human readable and understandable form. Okay, P is 3 decimal places and 2 decimal places. So you can actually format your output, floating point output. You can format it this way. Any questions so far? Anybody? Okay, so I'll just proceed. If you have any questions, anybody, you can interrupt me. Then reading input. Okay, so now this is, your displaying output on the screen. You're displaying output on the screen. Now let's say I want to take some input from the user. Okay, let's say I want to take input from the user. The function for that is input. Okay, so I could say something like this: X equals input. Okay, I just do like this. So I could say then print the value entered is X. Okay. Now it is asking me to give an input. I give 35.6. The value entered is 35.6. It is giving me that. Okay. But you see, when I run this again, you see the problem with this. The problem is it's just asking me. Okay, it's just giving me a box. There is no context here. I mean, it's not telling me, what am I supposed to do? It's just showing me a box. So how do I know what am I supposed to do? I put 77 here. It is giving it. Now I know. Okay, fine. It's asking me for a value to enter. Okay. So now, how do we actually, how do we actually make this give some more context to it? Okay. The way to do that is this input function itself. I'll change this. I'll just modify this a little bit. Okay, so here what I do is I just put a string here, enter some value. Okay, enter some value. So now what it will do is it is going to use this. It's going to use this whatever value, whatever string I have put as the argument of the input. It's going to just display that and display the output. Okay, so enter some value. Now it is telling me. Okay, now I know. Okay, I'm being asked some value here. So let's say 64, and it says the value entered is 64. Okay. Now the thing is, why we need this may seem to be very trivial. I mean, why do we need to do this? It becomes important. Let's say, for example, you are doing a problem. For example, let's say we'll do it after some time. That is, let's say the Newton's law of gravity. I want to calculate force of gravity between two masses separated by some distance. So in that case, let's say I want to give the choice to the user to enter the masses and the distance. Okay, so if I just give 3 boxes, then the user will not know where to enter the masses and where to enter the distance. So just to be able to indicate to the user, that first you entered a mass here, another mass here, and the distance here. Just to give this kind of a context, we need to use some string argument inside the input. Okay. Now one more thing that I would like to show you here. Okay. Now let's say I do something like this. So y equals input, enter a value. Now let's say I want to find out what is the type, what is the data type, what kind of data it is storing over here. Okay. So let's say I do this, and let's say I say 15. Okay. I say 15. I have entered the value 15. Now what is the data type? What is the data type for y? We'll immediately think that the data type of y is an integer, no? Because if I do type, I think I should get integer because I have entered 15. Okay, but let's just verify if that is indeed the case. Okay, so print the data type is, we can use the type y. Sorry, type y. Let's do that again. I entered 15 here. But you see, this is surprising. Data type is string. It is showing me a string. Remember this? What is the data type? Where was it? It was, yeah, data type, right? This is a string. Here R is a string. Similarly, it is showing me that even though I have entered 15, okay, even though I have entered 15 here, but it is not showing that it's an integer type. It is telling me that it's basically a string type. Okay, what has happened is the input function, whatever you enter, it will always take it as a string. Okay, this always is going to take it as a string. The reason for this is earlier, I mean, the input, it used to take, data as, integer floating types. The earlier version of Python, they used to take, the input used to take whatever value you had given, it used to give it as a floating point type. But that used to lead to a lot of confusion because you're expecting floating type. So by mistake, let's say I enter some text by mistake, then that will lead to an error. Okay, just by mistake. If the user enters some text, it is expecting a float, but it is giving a user, you have given a text. So that is going to give an error. So there is no way to know in advance, because what the user is going to enter, nobody knows, right? In advance, we really don't know what you're going to enter. So in order to prevent that, prevent this kind of runtime errors, everything, whatever you enter, it is, interpreted as a string. So how do I prevent that? That confusion, that is left to the programmer. It is a programmer's duty to make sure that the data that you have entered, okay, the data that you have entered, it is given, it is a proper value that you are actually expecting. So we could use some kind of a typecasting. Okay, I'll show you how to do that. So this is a string type. Even though I have entered an integer type, it is a string type. Okay. So now how do I do that? Okay. How do I convert this? We can actually do that. Let's say t is equal to input enter value. T is equal to input enter value. Now what I can do is x equals, I can convert this, let's say, into a floating type. I could convert this into a floating type. Okay, by using this float, this is a built-in function. Whatever you put inside as the argument, it will convert this into a float. If it can be converted, it will convert this into a float. Now, if I say print the entered value is x. Now let's, okay, just a second. I put the comma inside the quotations. Okay, let's say 16. You see, it has displayed a dot 0. It's 16. And if I can show the data type also, print type of for x 15. Now it has been correctly typecast as float. Okay, you could do that, or you could just do it directly instead of having a temporary variable. You could just say something like this. Okay, here in 2 lines you're doing. First, you're taking the input and then you're converting into float. But you can do both of these at the same in one shot. You can in one line itself. You can do so. Input enter value. Okay, you do that, and then this entire thing. Okay, this entire thing on the right hand side, I just copy. And then I do the float conversion here itself. Okay, so what it will do is you're calling the function, 2 different functions. First, it will take the input, whatever input you have given, it will then convert it into floating type, and that value will be stored into the variable x. Okay, so now I can just copy and paste this from here. Okay, is doing the same thing. So I'm just combine these two lines into one single line. All right, so any questions so far? Okay, so we'll now go to arithmetic operations. So what are the different arithmetic operations that can be done? Give me a second. Okay, coming back to this, the arithmetic operations. So there are many different arithmetic operations that you can do. Okay, so let's say I'm having 2 variables, x and y. X is equal to 7, y is equal to 4. Okay, so this I have done multiple assignment here. Then I create a variable called as z1. Z1 is equal to x plus y. That means it's just going to simply add both of them together. That is your addition, straightforward. Then this is subtraction. Okay, then this is multiplication. This multiplication, then you could divide them using this /. Then double star. Okay, double star means this is exponential, x raised to the power y. In C++, we use this one, the cap, right? So this is what is, no, in C we use POW, power. In LaTeX, if you're doing some typesetting, then you're using the power, this upper cap. But here you can't. In MATLAB, yes. In MATLAB or Scilab, you can use something like this. This is how you raise something to a power. But in Python, you can't do that. In Python, you have to use double star. So double star means you're raising x raised to the power y. Okay, and then this is one new operator. This is known as integer division. Okay, so what happens here is x and y, there x is divided by y, x is divided by y, and whatever is the result, that result is rounded down to the nearest integer. Okay, so x double slash y will give you what is known as integer division. And lastly, we have modulo. Modulo is x modulus y, x percentage y. This will give me the remainder after x is divided by y. Okay, so just putting x equal to 7, y is equal to 4. Just we'll see some of these outputs. You can just play around with them. Okay, so this is what you get. X plus y will give you 11, x minus y is 3, x into y is 28, x by y is 1.75, x raised to 7 raised to the power 4 is 2401. Then integer division will give us 1, okay, because it's 1.75, right? The division between of them is 1.75. It is rounded down. Rounded down means the lower integer, not the upper one. Okay, there are two possibilities. 1.75. The two integers are 1 and 2. 1 is below and 2 is above. But the rounding down, in case of integer division, the rounding down is always done to the lower integer. Okay, if you want to round up, all you have to do is the result of the integer division, just add 1 to it. Okay, that's going to do the trick. Then x modulus y, 7, when you divide by 4, the remainder is going to be 3. Okay, so these are the various arithmetic operations. Okay, so when two variables are of the same type, the result of the operation will also be of the same type, just some points. When they are of the different type, then the result will be of the more general type. So suppose I'm trying to do an operation between integer and float. Okay, let's say I'm trying to do an operation between integer and float. So let's say I have a equals 5 and b equals 6 point, right? So c equals, let's say, a plus b. Okay, that's simply I just put a plus b because I just want to see the result. The result is 11.0. Okay, because c, but if I put simply as c, the result will be 11 because both are integers. Both are integers, so the result also will be integer. But the moment I put a dot here after 6 in b, then b becomes a floating type. So the result also will be a floating type, which is a more general type. Integer and float, floating is the most general, so that's why it's going to be the more general type. Okay. Then the same precedence rules that in normal algebra that we follow, that BODMAS rules. So the same rules are followed in, if you are having lots of such arithmetic operators, the same precedence rules are followed. One more thing that you need to keep in mind is, if I write a statement like this, a equal to b plus c, please note that they are not equations, they are assignments. Okay, they are not equations. A equal to b plus c, it is not an equation, it's an assignment. Okay, that means it's not like you cannot do something like this. Okay, so you can't do something like this. Let me just put this over here. So for instance, if I say in algebra, no, if I say something like this, x equals x plus 1, okay, x equals x plus 1. Okay, so this is not allowed. This is not allowed in algebra. Why is that so? Because this would imply that, you know, x, okay, when I take the x on the other side, when I take this x on from the left hand side, if I to take it to the right hand side, what will be left behind is 0, and then we have minus x plus 1. So this minus and plus, let's say it gets cancelled out. Okay, then we're saying that 0 is equal to 1, which is a contradiction. It's not possible. So this kind of a statement, okay, this kind of a statement that x equal to x plus 1, it is not allowed in algebra, but it is very much allowed in Python. Okay, in programming languages, it is very much allowed. In programming languages, this is very much allowed, because what it means is, when I say, let's say x equals, let's say 7, and then if I say x equals x plus 1, let's say I do something like this, and then let me just print first, print x. Now if I say x equals x plus 1, x equals x plus 1, now if I try to print x, okay, it is taking the value 8. So in programming, what it means is The right hand side is evaluated. It takes the existing value of x, and to that existing value it adds 1. Existing value of x is 7, so 7 to 7 it adds 1, and whatever is the result it puts it back in the variable x. So the value of x can be changed. So this is different. This is an equation, this is an assignment. Okay, this, if you're trying to do this is an equation, this is an assignment. So that's the difference between doing this. So never interpret this as an equation. Okay, that in the sense that we can solve this equation, that is not actually allowed. Then the variable, the result of an expression involving a variable can be assigned to the same variable. So that's why as a result we could have something like this. So let's say I have x equals, I could do something like this, x star star 2 minus 2, and then if I do print x, okay, it's becoming 62. So what happened was, what is the current value of x? Current value of x is 8. 8 star star means power, right? X star star 2 means x raised to the power of 2. The value of x is 8. 8 to the power 2 is 64. Minus 2 is 62. So that's why it's giving me 62. Okay. Now it's become even more because I have done this. So I have to run this here, and this here is saying the existing value. Okay. Lastly, we have what is known as Python modifiers. This is something which we know, those who are doing C++ programming, you know that you can actually combine the arithmetic operator. All of these arithmetic operators, you can combine it with the equality operator and you can get a Python modifier. So if I say x equals 6, let's say x equals 6, okay, I could do something like this, x plus equals 1. I could do that, okay, because this is the same as, this statement is the same as, let me use a comment here, this is same as x equals x plus 1. Okay, what we have done here, x equals x plus 1, present value of x, to that you add 1. Instead of writing x equals x plus 1, okay, instead of writing x equals x plus 1, in between you just put plus equals. That is understood. So if I say print x, okay, it will show me 7. Okay. Likewise, you could have for the others also, you could have, subtraction also, you could do something like this. So instead of x equals 6, instead of plus, we could put a minus here. So this is the same as x equals x minus 1. So this is going to give me 5. Again, I could have something like a product here, x star is multiplication, is equal to, let's say, minus 3.7. Oops, just a second. Minus 3.7. This is the same as x equals to x times 3.7. X times minus 3.7. Okay, it's the same thing. Okay, so that's the value that you got. Okay, similarly, the other operators also, they will also work. X equals 6, let's say, and if I do x slash equals, let's say, 5, this is the same as x equals x by x divided by 5, okay, which is 1 by 2. Then you could have the integer division also. You could have an integer division. So x double slash 1, let's say x double slash 6, let's say 6.5, it should give me 0. This is the same as x double slash 6.5. Okay, it gives me 0 because 6 divided by 6.5, that will be less than 1. So round it off to the nearest integer, that is going to give us 0. So that's about the Python modifier. So this completes the first part of this presentation on elements of Python. Okay, if anybody has any questions, you may ask me before I move on to the next topic, which is flow control, how to control the flow of logic in your Python program. You may, if you are not able to speak, you can put your question in the chat box as well. Anyone? Okay, so if you don't have any questions, you feel free to email your questions to me at any point of time. So without wasting any more time, let me just go to the next part. First, I'll save this. And what I'm going to do is, let me just show you what I'm going to do. I'm going to just convert this into a PDF. Okay, I'm just going to convert this by going to File, Download As. I'll convert this into a PDF and I'll send that PDF to you all. So you will get the input as well as output, everything, whatever I've done here, you will get this here. Okay, so let me just close this and I'll move on to the next one, which is flow control. Okay, flow control, that is how the logic, how it flows inside a Python program. Okay. So first things first, what are the constituents of a Python program? What are the building blocks? Okay. What are the building blocks that make up a Python program? So fundamental building blocks are known as, there are three types: literals, variables, and operators. The fundamental building blocks are literals, variables, and operators. Okay, and using these literals, variables, and operators, you can create what are known as expressions. Expressions are the segments of code which perform computations, parts of the code which perform computations and which can return values. So something like x plus y, okay, that is an expression. A plus b star star 2, that is an expression, because this is a unit that can perform computation and it can return values. X plus y, if x is equal to 1, y is equal to 2, this part x plus y will give us, will be able to do the computation 1 plus 2 and it will return values. So in the Python prompt, you can actually put expressions and it will evaluate and it will show you the value. What is a statement? Statement is a complete unit of execution. Okay, so if I say a plus is equal to 10, okay, a plus equals 10, that can be written as a equals a plus 10. Here a is an expression, a plus 10 is an expression. You can combine different expressions using the equality sign and you can get a statement. Okay, so statement is made up of expressions. So remember this: literals, variables, operators, we can use that to make expressions, and expressions we can use that to make statements. So all these are basically statements, and many such statements, when you combine them together, okay, and let's say you can use this group of statements, you combine them together in such a way that you can use those statements as a group anywhere, that is known as a block. Okay, so you need to keep in mind these things. The most fundamental building blocks: literals, variables, operators. Literals, variables, operators, they make up expressions. Expressions make up statements, and statements make up blocks. And blocks make up a program. Okay, so to understand this, we have I have some diagrams over here. So this is what I mean. Okay, so when I say literals, variables, operator, this is a variable. Okay, we have already seen what is a variable. Okay, this is a block. I'll tell you what this is. Okay, this is a basic, this is known as a function. We will be discussing functions very soon. So this is K2. K2 is a variable. Okay, now what is a literal? Literal are actually, it means literal values. Okay, so when I say x equals 1, x is the variable, 1 is the literal. Okay, so the values are known as literals. So 6.582 e minus 16, this means 6.582 into 10 to the power minus 16. This is a literal. Okay, this is a literal. K2 is a variable, and these star star plus forward slash equal, they're all operators. Okay, so literals, variables, and operators, this is what they are. Okay, this is a variable, this is a literal, and this is an operator. Just an example. So now this literals, variables, and operators, you can see here, for example, in this case, okay, 2 star m star e minus v. Okay, here 2 is a literal. You can see 2 is a value, no? 2 is a value. So 2 is a constant value. So 2 is a literal. M is a variable. E is a variable. Okay, what about star, star, and minus? They are all operators. So what do you have in this highlighted area? What do we have? In this highlighted area, we have literals, we have variables, and we have operators. So when you get literals, variables, and operators, when you combine them together, you get an expression. So this is an expression. Okay, so this is an expression. So expressions, what are they made up of? Expressions, they are made up of literals, variables, and operators. Then consider this line, in this line. Okay, so in this line, you can see here, in this line, this k1 minus k2, this is an expression. Similarly, K1 plus K2, this is an expression, right? And then when this entire thing on the right hand side, this is an expression. So this is one expression, and then you use that expression and then you write one single line. Okay, this is one single unit of execution instruction. So this is one single, I'm saying that R is equal to this expression, this expression, this expression. So a collection of all these different expressions that makes a statement. So this is what is meant by a statement. So in other, how do you recognize a statement? You can just recognize a statement because a statement, it spans one full line. Okay, expression could be a part of a line, but a statement is one full line, or statement contains many different expressions together. So this is a statement. Okay, so variables. So you can see here again, same thing. Many expressions make up a statement. Okay, and then now you can see all these lines that we have, all of these are statements. Apply the same definition. This is a statement, this is a statement, all of these are statements. Okay, so all these statements, you take them together, this becomes a block. Okay, because whenever I call this function, all of these statements, they are executed one after the other. They are always executed together. So because they're executed together, we call them as a block. Okay, so to summarize, this is what we have. So we have variables, literals, operators. Variables, literals, operators, together they can form an expression. Expressions together they can form a statement, and statements together they can form a block. So this is like a hierarchy. At the topmost level we have block, below block we have statements, below statement we have expressions, and under expressions we have variables, literals, and operators. So this is how this is the constituent of a Python program. And of course, in the program, in a Python program, we could have many different blocks. Many different blocks make up a Python program. Okay. Now, the basic structure of a Python block, this is something that you need to keep in mind because this could be a source of error. Okay. So this is how a block structure looks like. So a Python block, it always starts with a block statement. It tells you what kind of a block it is. Then the block statement is followed by a colon. You need a colon. And then in the next line, you have to indent the line. That means you have to give some kind of a gap. That gap could be 1 space, 2 space, 3 spaces, or 1 tab. Okay, but whatever be the case, all the lines should have the same gap. If you're using 1 space, the next line also 1 space, third line also 1 space. So all the lines should be having the same space from this block. So this is known as indentation. If you're using 1 tab space, then all the lines will have the same tab space. So this helps you to identify which lines belong to which block. Okay. Now this is a very common source of error for somebody who is beginning to work with Python. The source of error is this this colon and this indentation. Okay, this is a very common source of error. So never forget these two. Okay, never forget to put a colon after the block statement. Never forget to indent the sub-statements, the body statements of the block. Okay, so these are some things that we need to keep in mind. Now, why do we need this indentation? What is the significance of indentation? Many uses are there. First of all, it makes your program easy to read. It is because it is used to define a block of code. By the way, the block is also known as a suite. Then continuous statements that are indented to the same level are considered to be part of the same block. So just by looking at the indentation, you know these lines, they're all part of the same block. Okay. So every block statement, whenever you have a block statement, that is a statement followed by a colon, every block statement should be followed by at least one line which is indented. If suppose I put a colon, that means Python is expecting the next line will have some indentation. But suppose I don't put an indentation, then Python is going to give me an error. Okay, we'll see that. I'll demonstrate this error and we'll see how this really happens. Now we will be studying sound blocks. So this is basically the abstraction. Okay, this is basically the abstract ideas that we have here. Okay, to understand flow control, we need to remember all of these. Okay, now we'll actually go to some specific types of blocks. We'll go to some specific type of blocks. The first one will be what are known as conditional blocks. So conditional blocks, what are they? Just give me a second. Conditional blocks, as you can see here, they work on some conditions. So you can use certain conditions to make some logical decisions. Okay, if you want to use some conditions to make some logical decisions, so that is known, these are known as conditional statements. Okay, so in Python, what are some of the conditional statements? One is if, another one is else, and another one is elif. Okay, so if statement, it is used to execute a block of code if a condition is true. If the condition, if a certain condition is true, then you use the if statement. But if this same condition, if it is false, then we use the else statement. Okay, so this if else, it works if there is only one condition and that condition could have either true or false value, then we can use a if else condition. But there is one more option, that is elif. Okay, suppose there is one condition and on top of that condition, let's say there is one more condition that we want to test, then we can use a elif. Okay, so let's see that. Okay, let's first look at the syntax and then we will do some examples. Okay, so this is the example. I just picked this up from this website. I mean, it has got very excellent resources for beginners. You can just go to this website and you can actually learn a lot of basic ideas. Okay, just to get started. So this is how a if block looks like. So if, you have to write if followed by the condition. Okay, then that condition, after that you have to put a colon, and below that, putting proper indentation, you write down the statements. Okay, so this is the true branch. This green, which is written in green, that is a true branch. This branch is whatever these statements, they are executed whenever this condition is true. Okay, and it must be indented. Then after that, following statement, those statements which are not part of this block, they will again go back to the original indentation and they will follow. Okay, so let's say, take an example. Okay, the example is, I want to check if two numbers, I have two numbers, I want to check if one number is lesser than the other. Okay, so let us say I have A and B. Okay, let's say A and B. I call A, I'm assigning 5, and B, I'm assigning 9. I want to check if A is lesser than B. Okay, so for that I could use a if block. There's only one condition I want to check. I want to check if A is less than B or not. If A is less than B, it will just display that A is less than B. Okay, so I could say that if the condition, okay, this is the syntax, if followed by the condition. What is the condition? The condition is A is less than B. If A is less than B, never forget the colon. You always need a colon, and then press enter. Jupyter Notebook is automatically going to indent this. You can see here. Okay, if I just put enter, nothing will happen. Okay, but if I put a colon here and then put enter, it indents this. It automatically tells me where to start the next line. So then I do print. Then I say A is lesser than B. Okay, run this. It is coming correctly. Okay, but if I do the other way around, let's say this is, let's say 15, A is 15, B is 9. If I run this, then nothing will happen. Nothing will happen. It has put A, it has taken the value 15, B, it has taken the value 9, but it will check. It goes to this line, it checks. Is this condition satisfied? Is 15 less than 9? Answer is no. Because answer is no, it will not execute this. So this will not be executed. It just comes out and nothing happens here. Okay, so this is how a if statement, this is how it works. Okay, then you could also have nested if statements. Okay, you could have multiple statements like this. Let's take an example. Example is, let's say I'm having three numbers, A, B, and C. Okay, there's three numbers. Let's say I give this as -2, 9, and let's say 5. Okay, now I want to check whether A is lesser than B. First, I want to check if A is less than B. Okay, let's do that. So if A is less than B, okay, let's check if A is less than B. If A is less than B, then we need to print A is, let me use the values, A is lesser than B. A is lesser than B. Okay, if A is less than B, okay, when I run this, yes, -2 is less than 9. Okay, so it's fine. Now I also want to check if A is less than C also. Okay, I want to check if A is less than C also. So basically I want to know if A is the smallest of the three numbers, if A is the smallest of the three numbers. Okay, when will A be smaller than the when will A be the smallest? A will be the smallest if A is less than B as well as C. So I could have one more condition inside. If A is less than C. Okay, so what it does is first it checks if A is less than B. If it is satisfied, then it goes inside. Okay, if A is not less than B, then it will not go inside at all. Now, once A is less than B, then it will check again if A is less than C. If A turns out to be less than C, then we can say, I'll say A is the smallest number. Okay, let's run this. -2 is the smallest number because I have chosen -2, 9, and 5. So -2 is the smallest number. Now let us say I put here -5. Okay, now only this condition is satisfied. Only this one is satisfied. Then it goes here and says that it is not at all satisfied. Okay. Again, now let us say I change this. Okay, 9. Okay, instead of 9, I put, let's say, -9. Okay. Now nothing will happen. Why? Because this condition itself is not satisfied. Even though A is less than C, but this condition it never reaches that condition because the outer if statement, it does not allow that because it first checks. Okay, A is less than B, is -2 less than -9? Answer is no, so it will never go inside. It never goes inside this if block. If it never goes inside, then this will never be checked. If this is never checked, then this is also never going to be executed. So this is what is going to happen. Okay, so this is about nested if statements. Okay. Then next, so this is if I have just one condition to satisfy. What about the other condition, the condition where the condition is not satisfied? In that case, you can use a else. Remember, else is always used in combination with if. Okay, you cannot simply use a else statement just like that. We have to have a if condition. Okay, so you first start with an if condition. Okay, if this is the condition, if the condition is true, it will execute these green colored statements. If suppose the condition is not true, then it will go inside the else block, and then if this condition is not true, it will just execute all of these the purple statements. Okay, because they belong to the else. Okay, so this is the syntax of the else statement. So let's take a example. Okay, example is let us say I want to take from the user a number. And I want to check if the number is an even number or an odd number, and based on that, I want to give a display. So let's say a variable called as num. Okay, and let this be an integer type. How do you take data from the? How do you take input from the user? So we can use a built-in function called as input. And then just to give some context here, we say enter an integer. You'll get the integer. Now I want to check if I want to check if the integer whether it's even or odd. The integer whether it's even or odd. So how do I do that? Okay. So for that we can actually use this modulo. Remember this modulo symbol. So if this one A modulus B. Remember that. What does this do? It divides A with B. And whatever is the remainder, that is the result. Okay. So A modulo B, it gives the remainder when A is divided by B. Let me put this as a comment. So I can use this modulo to find whether something is an integer or not. So all I need to do is I need to just find whatever number is there. I need to take the modulo with 2. That's all. Because how do you check if a number is integer is even or odd? You divide it by 2. If the remainder is 0, it's an even number. If the remainder is 1, it's an odd number, right? So you can use that. There are 2 conditions. If it's a even number, then the condition must be that the remainder is 0. Else, if the remainder is not 0, it has to be 1. Then that's the other condition. So we can actually use this too in this particular case. Okay. So what I can do is I could have again an if condition. So num modulo 2. Okay. Double equal to means you are checking if it is indeed equal to. Single equal means assignment. Okay. That will always be true. Double equal to means you are checking. This double equal to means you are checking. Okay. You are checking for the condition. You are checking if this quantity, when you divide by 2, whether the remainder is 0 or not. Okay, if the remainder is 0, then print you have entered an even number. Okay, you have entered an even number. Done. Then if in case this remainder is not 0, the only other possibility is 1, so we don't need to actually specify that one. Else we can say that print you have entered an odd number. Okay, let's run this and see. Enter an integer. Okay, let's say enter 16. It gives me, it's an even number. Let's say enter another. So let's say I give 89. It's an odd number. Okay, so when I had given 89, when I entered 89, so 89 modulus 2, the remainder is 1. 1 is not equal to 0. 1 is not equal to 0. Then it goes to the else condition. You have entered an odd number. Okay, when I gave 16, 16 divided by 2, the remainder is 0. Because the remainder is 0, this condition is satisfied, so it prints you have entered an even number. So like that we can check whether a number is even or odd. Okay, so this is if else statement. Okay, next there is something called as, okay, let me just run this. Okay, next there is called as a if elif. Okay, elif means else if. Okay, that's what it means. Okay, so elif, to be able to use elif, you need an if else already. So there should be an if block and an else block. In between the if and an else block, suppose there is one more condition that you want to check. That one another condition, you can put it inside an elif block. So you put a condition in after if, and you put a condition inside elif block, and then you can evaluate them. So when this condition is satisfied, the green lines will be satisfied. When this condition is satisfied, the orange lines will be executed. And none of these two conditions are satisfied, this will be executed. So let's do an example here. So let us say a b equals 15 comma 13. Okay, so I want to check whether a and b are they if a is greater than b, or if a is less than b, or b is less than a, or if both are equal. These are the three things that I want to check. Okay, so for that what I do is I do this. If a is less than b, if a is less than b, then we print a is lesser than b. Okay, now I also want to check if b is lesser than a. Okay, there is one more condition that I want to check. B is lesser than A. So for that I use an elif. Elif B is less than A. This is one more condition that I want to check. And I say print B is lesser than A. Okay, so these are two possibilities. Either A is less than B or B is less than A. Accordingly, it will execute either this or this. There is one more possibility. The other possibility is A is neither less than B, B is neither less than A, that is, they must be equal. So that one we can put it under else. Okay, else print A and B are equal. Okay, now let's run this. A is 15, B is 13, so 15 is less than 13 is less than 15. Okay, B is less than A, so this condition is satisfied, so this will be given as the output. But if I change this and make this 5, now it will show the first condition, A is less than B, 5 is less than 13, so this will be the output. Okay, A is lesser than B. But if I put 5 here, A and B are equal, because neither this is satisfied. Neither this is satisfied nor this is satisfied. Only that means whatever is left, okay, the possibility that is they must be equal. Okay, so this is what we have. Okay, so this is your elif statement. Okay, then I use these comparison operators. You see, I have used these comparison operators here. Okay, I compared this less than, right, and here I have used this equal to. These are known as comparison operators. These are known as comparison operators. Python allows us provides us many different comparison operators. So that is given by in this table. Okay, that's why I mentioned. By the way, I had mentioned in the when I had given you the introduction to Jupyter Notebook, you can also create tables, right? This is a table. This is a table that I have created. Okay, so all you need to do is I want a table in which there are 3 columns. So you just use text. You just type your table like this using that vertical bar and horizontal dashes. You can do that to segregate the different rows. So this is one row, right? This is one row. The elements of the row, they're separated by the vertical bars. Then after the first row, this is the title row. This is the title row. How do you identify the title row? You just put a set of bars here. Of course, you have to use the horizontal. You put a set of dashes here, and of course you have to put the horizontal vertical bars to show that these are the columns. And then after that, you just put the rows. Okay, this is the first column. This is the second column, and this is the third column. Like that, you add all of these. And when I press Control and Enter, it is going to create a nice looking table, okay, which is going to display this. Whatever I have typed is just going to display this. So equal to means you check whether if A is equal to B. This is how you check it. So you check if A is equal to B. Then exclamation equal means does not equal to. Okay, if I want to check whether something is not equal to, then I can use this. So the same thing, in fact, you can do it this way also. Let me write this 16. Okay, you got this. Now the same thing can be written in another way. The same program, the same code can be written in another way. Let me show you how. Okay, so I could do it something like this. I could put the odd here and I could put the even here. Okay, now I just have to change the condition here. The condition is instead of equal to, I put exclamation equal. This means not equal to. So when I run this 16, it is again an even number. It will still work. Okay, so that's your negation. Okay, negation. So this is greater than, this is greater than or equal to, less than equal to, and so on. So as just you can just try out. Okay, some of these, just use some of these operators inside a if, else, and if else block. Okay, just play around. Next, you could use multiple conditions. Inside the same if, you can actually use multiple conditions. Let me see how. Let's do an example. So let us say X, Y, and Z. Let's say I have 3 numbers. Okay, let's give some values. So let's say one is 9, another one is, let's say, 8, one more is, let's say, 3. Okay, now I want to check in one shot itself. I want to check whether X is the largest number or not. I want to check if X is the largest number or not. One way to do that is, I want to check if X is the largest number. I can check if X is greater than Y. Okay, first I check if X is greater than Y. Then I again check if X is also, after X being greater than Y, I also check if X is greater than Z also. If that is true, then you can say print X is the largest number. Okay, X is the largest number because this is 9. But you can see here I can use a nested, I can use nested if else if conditions, but we really don't require this because these are just 2 conditions. I could just put these 2 conditions together. Okay, I could just put these 2 conditions together in the same line. Okay, so another way to do that is like this. Another way to do that is this way. So if first condition is X greater than Y, next condition is X greater than Z. Okay, now what I do is in between these 2 conditions, it is always good to put these conditions inside brackets, because then you will be able to identify which are the conditions. So this is one condition. Even if you don't put bracket, it will still work. This is one condition. This is another condition. These are the 2 conditions that I have used here. In between them, just put and. That's all. Okay, and then I type print X is the largest. Okay, in both cases it will work. So instead of having nested if conditions, always it's better to put the multiple, if you have multiple conditions, just put them together in the same if statement. Okay, so this is one thing that this is using, this is logical and. Okay, this is logical and. If you've done logic gates, Boolean algebra, you know what I'm talking about. Logical and. Similarly, you can have logical or also. Okay, let's say I want to check if, this out of this x, y, z, I want to check if x is not the smallest number. I want to check if x is not the smallest number. Okay, let me delete this. I want to check if x is not the smallest number. How do I check that? We can do it this way. So if x is greater than y, or if x is greater than z, either of these two conditions, if they're satisfied. Okay, two conditions, first condition or second condition. The first condition is x is greater than y, or x is greater than z. If either of these two conditions are satisfied, any one of these two, I could combine them. This is known as a logical OR. Then then this entire condition is satisfied. Then we can say print x is not the smallest number. Okay, x is not the smallest number, obviously. So now let's say I put x equals to 1, right? This is how it's going to be. Now you can also put a else condition here. Else print x is the smallest number. Okay, x is the smallest number here. Okay, but the moment I put 10 here, x is not the smallest number. So here I have used a logical OR operation to combine two different conditions. Okay, so you can combine them this way. Then there is logical NOT. You could negate a condition also. Suppose I have a condition like this: x comma y. Okay, x is equal to, let's say, -2 and y is equal to -7. Okay, I want to check which is larger. Okay, I want to check which is larger. One way to do that is, which we have done, if x is, I want to check if x is larger. If x is greater than y, then we print x is larger, and when you run this, we will indeed get this. But there is another way to do that. Another way by which you can do that is, instead of x greater than y, I could put x less than y. Obviously this will not satisfy the condition, but then in front of this condition, if I put, always good to put a bracket, because that will give us an indication. Always in front of the bracket, I could always put a NOT here. If not x less than y, then x is larger. So this is a logical NOT negation operator. Okay, any questions? Okay, now conditional operators. This is one more fun way by which you can actually select two statements in the single line using existing condition. This is just a shortcut which actually Python provides. So let's say I have another thing. So x comma y equals 3 comma 9. Let's say I have something like this. Then what I want to do is, I want a value of z. Okay, what I want to do is the value of z. Okay, z will take the smaller value out of these two. Okay, which is the smaller value here? The smaller value is 3. Okay, I want z to take the smaller value out of these two. But what if x is, let's say, 15, right? In that case, z should take the value 9. So how do I do that? In one line, using conditional operators, actually you can achieve the same thing. Okay, it is just like your conversation. So what is the conversation? What are we looking for? Okay, the logic that we are looking for here is this: z should be equal to y, z should be equal to x if x is less than y. Okay, else if x is not less than y, that means z should take the value y. So in English, I mean, suppose if you're having a conversation, how will you say this? I want z to take the smaller value out of x and y. Okay, how do I do that? If you're just having a conversation, this is how you'll talk about it. You'll say z is equal to x if x is less than y, else z is equal to y. So we can write it exactly in the same way. So z is equal to x if x is less than y. Okay, else it will take the value of y. Okay, now let's run this. Okay, let me print print the smaller value is z. Let me run this. The smaller value is z, which is 3. Now if I put, let's say, -9 here, run this, the smaller value is -9. So you see, it's doing that if else condition, it is doing in one single line. Okay, wherever you see, we can now the same thing. Okay, this same line can also be done in another way. Okay. First let me put the comment somewhere on top. Okay, now the same thing, it can be done this way also. I could do it like this. If x is less than y, okay, if x is less than y, then z equals x. I hope this works. Else z equals y. Okay. Print. Let's copy this line. Let me use some other variable. Let's say w. The smaller value is w. See, it works. I mean, it's the same thing. But thing is, here there are 4 lines. These 4 lines you are just writing in one single line. Okay, so this is conditional operators. Okay, so you can it actually gives you an immense amount of shortcut way of doing things. Okay, so this is what we have. All right. Now let's use this, whatever knowledge we have gained so far. Okay, whatever knowledge we have gained so far, let's use this to actually calculate something. So to do some physical computation. Okay, so the problem that we have is a very simple problem. Everybody knows about this. Okay, so we have two particles whose masses are m1 and m2 in kilograms, and their centers, there are point masses. So their centers are separated. Okay, in meters. And it calculates the gravitational force between them in newtons, and it prints the answer. Okay, so how do I go about doing this? The formula is this, the value of g is this. So how do I go about doing this? First thing first, put the constants. Okay, set the values of the constants. So constant is g. So what is the value of g? G is 6.67 into 10 to the power minus 11. So this is scientific notation. So the way to write scientific notation is 6.67 times 10 to the power minus 11. You have to put e, exponent, e for exponent, minus 11. This is going to set the value of g. Okay, now what does it do? It takes as input the masses of the two particles. Okay, so let's say I create a variable called as m1. Okay, now what do I want to do? I want to take from the user. And m2, again I want to take from the user, and the separation between the two masses are also I want to take from the user. Okay, now we know that input, the result of this will be string. You cannot perform mathematical operations on a string. So what I have to do is I need to convert this into a floating type. Okay, same thing over here also. Float. Similarly here. Okay. Now next what I do is, okay, let's just run this once and see. Okay, so it is asking me, okay, it is asking me, let's say 1, 1 and 1. You see, but there is no context here. What are these ones, right? So to give some context, what we do is we put a string here to make it understandable. So enter mass 1, enter mass 1. Then similarly here, enter mass 2. And lastly, enter separation, this, enter separation between the masses. Okay, I'll just also mention here, because we are doing in SI units, in kg. Here also in kg, and the separation will be in meters. Okay, so we get the values here. So now it is going to give me proper floating type values. Okay, next thing that I need to do is I need to calculate now what is f. So all I need to do is f equals you're doing G, you're doing capital G times the product of M1 and M2 divided by R square. Okay, always put the brackets here. So we have numerator, denominator. So this bracket is the numerator and this bracket is the denominator. So numerator, what is that? Numerator M1 times M2. Denominator, what is that? R square. How do you take square? Double star 2. That is going to give me the square. Okay. So we have calculated the force. Now we just need to print it out. Okay. So the force between the masses is the force between the particles. The force between the particles is F, and of course we are providing the answer in newtons. Okay, we are providing the answer in newtons. So let us say first one is 1500, next one is 2300, separation between them is 0.05. Then this is the force 0.009, right, into yeah, these many places. Okay, this many newtons. Now the thing is, I mean, we don't want, okay, we're not really satisfied with this. So how do we do that? We can do that using formatting strings. We can format the string here. So you can use a C style formatting string format. So percentage, okay. So let's say I want how much? Till here, let's say I want. So how many significant figures? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 significant figures. So 6 plus 1 is 7. Okay. 1, 2, 3, 4, 5, 6. 6 significant figures plus 1 is 7 and 5 decimal places. So 7.5F. Okay. And then we put a percentage here. 1500, 2300, 0.05. Okay. 1500. Oh, sorry. Let me run again. 1500, 2300, 0.05. Okay, so this is giving me the output the way I wanted. It's showing me the output. Okay, so this is one example of how you can easily do calculations like this. Then next one is a satellite which orbits the Earth. The altitude of a satellite is given in this way. G is this, mass of the Earth is this. Here capital M is the mass of the Earth. R is the radius of the Earth. Okay, so you have to write a Python code to ask the user to enter the value of t and print out the altitude in kilometers. Then use this code to calculate the altitude of a geosynchronous satellite. The actual time of a geosynchronous satellite is 23.93 hours. How much difference would it make to the altitude of the satellite? Okay, so let me do this over here. Okay, so in this case, again, the constants, so value G. So you can just take the value of G here. All the constants we write down first. Then another constant is mass, M. Okay, M is 5.97 times 10 to the power 24. So 5.97 E24, that is going to give us in scientific notation. Then R, the radius of the planet, the radius of the Earth. The radius of the Earth is 6.37 into 6.371 into 10 to the power 6. So 6.371 into 10 to the power 6. We write it like this. Then yes, we need also pi. You need the value of pi. You can get the value of pi from a package called as math. Okay, I'll show you in detail. Import pi. We can get the value of pi. There is a package called as math, and this math, it gives me the value of pi. The value of pi is already calculated there. I could actually use this directly. Okay, so we can take the value of pi from there. Okay, so now all we need to do is find out we need the time period. Okay, from the user it will take the time period. Okay, so this is going to be a floating type. So I want to take it from the user, so we take it as an input, and then we give some text to make the user understand. So enter the orbital time period of the satellite. Orbital time period of satellite in seconds. We'll give the time period in seconds. We'll provide it in seconds. Okay, so we'll have to do some calculations before we actually give the input. So then the value of h, you can calculate the value of h. The value of h will be this one. So we can, if you look at the expression, there is a big bracket, and this bracket is raised to the power of whatever this quantity inside the bracket. We'll fill it up later. First, we'll get the skeleton of this, the exoskeleton of this formula. We'll get this in place. So this entire thing inside the bracket is raised to the power 1 by 3. So bracket star star another bracket, and in this bracket I'll put 1 by 3. Okay, and outside this we have r. Okay, now we need to put things inside this bracket. Inside this bracket, inside this big bracket, there is a numerator and a denominator. So first we'll put a bracket for a numerator, then we'll put another bracket for the denominator. Okay, now in the numerator, what do we have? We have gmt square. So g star m star t, and how do you get square? Star star 2, gmt square. In the denominator, we have 4 pi square. So 4 into pi, we have already included from the math library. Okay, so from the math package, pi, and how do you get square? Okay, so this is what you have. So it calculates the h, and then finally print the altitude of the satellite is, the altitude of the satellite is h, and we are expressing, everything is in SI units, so we are expressing in meters. Okay, all right, now before we actually run this, let's do some calculation. Okay, first what could be the time period that we will provide? Okay, so the minimum time period for a steady orbit is 90 minutes. Okay, minimum time period is 90 minutes. Okay, 90 minutes, and we have to enter this in seconds. 90 minutes into seconds, 60 seconds. Okay, so 5,400. Yes, 90 minutes, 60 seconds, 5,400. So that will be the one. So let's just apply, enter this and see what we get. 5,400. Okay, it is giving me 279,321 meters. Okay, so in kilometers, we can actually calculate this in kilometers. Let's provide this in kilometers. How do you get in kilometers? Just divide by 1,000. Okay, so how to divide by 1,000? Very next line, I'll put h by equals 1,000. Okay, because if you remember, this is the same as h equals h divided by 1,000. Okay, so this is going to convert this into kilometers. So now we will just km here, run this 5400. It gives me 279.32. Okay, now we need to do something about the formatting here. So to take care of the formatting, again we'll use those C style formatting strings. So we want how many? 1, 2, 3, 4, 5, 6, 7. Let's say 7. Okay, 8 significant figures. 8 significant figures means 9 and 2 decimal places. 9.2f percentage 5400, and there is 279.32. Okay, so that's what is given over here. That's the answer that we got. Now the next part of the problem, is use this code to calculate the altitude of a geosynchronous satellite. Geosynchronous satellite. What's a geosynchronous satellite? It seems to lie over the same place. It seems to be stationary over the same place at all times. So because the Earth rotates, takes 24 hours to rotate. So if the satellite has to remain in place, in position over the same place, it should also rotate along with the Earth 24 hours, right? So we want to calculate, find out how much is 24 hours. So the time period of a geosynchronous satellite will be 24 hours. So 24 hours into 60 minutes into 60 seconds. This is 86400, and this 86400, this will be the input for this code. Okay, let's run this 86400. So the altitude of a geosynchronous satellite is 35,856 kilometers. That's the altitude of a geosynchronous satellite. Okay, now what is saying is the actual time period of a geosynchronous satellite is 23.93. Okay, 23.93. How much difference would this make to the altitude of the satellite? Okay, so for that, what we need to do is, let me just calculate here again. I'll get one more cell here. So we'll convert 23.93 hours into seconds. 93.93 hours into seconds. This gives me 864148. Okay, these many seconds it gives me. Then in this one, because what we want to do is we want to find out what is, because h is directly proportional to t, so 24 hours will give me the greater value. Okay, so I'll just note down this value here. I'll just note down this value here because I want to find out the difference between the two. So this is if you consider 24 hours. If you consider time period of geosynchronous satellite to be 24 hours, then this is going to be the altitude. So now what we do is let's run this again. This time I'm going to use this value for 23 hours. That means these many seconds. Let's use this value. Okay, so now the altitude I have got is this one. Put this back here, run this. So the difference, okay, if you assume the geosynchronous satellite, the time period to be 24 hours, okay, and the actual time period for a geosynchronous satellite, the actual time period, the difference in altitude will be around 82 kilometers. That's the difference in the altitude of the satellite. Okay, so just by using this, we are actually able to solve this problem and investigate even what happens in this case. Okay. We are now 3:30, so maybe I'll take another 15 minutes. Okay. All right. Next, we come to iterative statements or loop statements. I think we're almost done. I think loop statements, that will be the end of it. Yeah. Okay. We have packages. So we can discuss that along with the next one, which is tomorrow. So iterative or loop statements. Okay, these are statements that allows the user to repeat a set of steps. As long as a certain condition is satisfied, it allows you to keep on repeating the same set of steps. Now, usually as human beings, we don't like to do the same things again and again and again. But because it's a computer, it does not mind doing the same things again and again. So as long as the steps are nicely defined, and as long as the conditions are satisfied, it is going to keep on doing the same steps again and again. So Python provides us two such statements, iterative statements. One is a while loop, another one is the for loop. Okay, so let's look at the syntax of the while loop. So this is how a while loop looks like. So while, okay, while, then it will check for the condition. Okay, while it will check for a certain condition. If this condition is satisfied, then it will, perform these statements. Okay, it will perform these statements, and it will keep on performing this statement so long the condition is satisfied. So you have to be extremely careful that this set of statements, it should contain some termination. Okay, it should terminate. That means there should come a point where this condition is not satisfied. Otherwise, what will happen is it will keep on repeating these steps again and again and again until you run out of computer memory. So always we need to ensure that there is some kind of a termination condition which always is applicable. Okay, so that is going to make sure that this does not go into an infinite loop. And if suppose this condition is not satisfied, then what do I do? Then you could also have a else block, okay, under the while loop. So let's take an example. Okay, this is an example which I have just borrowed from the lab course from our BSc first year students. Okay, just give me a second. Okay, so by the way, Samrat, are you able to add the participants if somebody comes?
No, I am not seeing anybody coming also.
Okay, I just saw a couple of people. One of them I added, the other one before I could add, it is just notification vanished. Anyway, so let us do this problem here. Okay, the problem is, suppose I have a body which is at initial temperature T0, okay, and it is placed in an environment T environment. Okay, then the instantaneous time after some time T, the temperature of the body will be T environment is given by this formula. The temperature of the body after some time will be given by this formula. This is known as the Newton's law of cooling. So I could actually find out, okay, I could actually, have a lot of different temperatures, and for each of this temperature, I could have a lot of different instance of time, and for each of these instance of time, I could find out what is the temperature, and I could display them in the form of a table. So basically, this is what I'm planning to do over here. I want to display this as a table, okay? So we're going to do this. So for that, first of all, I'm going to use, because it contains, you see, the exponent, right? E to the power minus. So there is a function called as exponential function. We need that function. That function is available in the math package. So I'm going to import that. So from math, import the exponent function. Okay, so now I want the initial time. At what initial time I want to measure the temperature? Initial time, let's keep it as 0. Okay, initial time, let's keep it as 0 seconds. So basically this is initial time in seconds. Okay, then we have final time, TF. Okay, after how many seconds, till how many seconds you want to keep on calculating this? Let's say I want to give this as 5,000 seconds. Okay, this is the final time in seconds. Okay, so now how many divisions from 0 to 5,000? How many divisions, how many sub intervals do you want to make? Okay, the number of sub intervals, number of divisions that I want. Let's say I want to make just 10 divisions. That means in this table, the table that we are trying to obtain, there will be just 10 rows. Okay, just 10 rows. Okay, not 10 rows, 11 rows, because the number of divisions is 10. So the number of samples, because we will have one sample before, one sample after for one division. So the number of samples will be always number of divisions plus 1. Okay, so 10 divisions means there will be 11 samples. So the number of samples of time that we'll have to take is going to be number of divisions plus 1. Number of divisions plus 1. Now what is the delta t? What is the delta t? The sub interval time, that will be simply final time minus initial time divided by the number of divisions. So I have divided 5,000, 0 to 5,000 seconds into 10 divisions. So what will be the size of any one sub interval? It will be 5,000 divided by 10. So 5,000 minus 0 divided by 10. So I could call this as delta t. Delta t, it will be simply equal to the final time minus the initial time divided by the number of divisions that I consider here. Okay, so this is what we have. So now the next thing I need to take from the user, the initial temperature and the temperature of the surroundings. So let's take from the user. I'll create a variable called as t_0, t0. Okay, I'll take from the user. So I have to use the input function, but then I have to typecast it to float input, enter initial temperature, and of course I have to mention that it is in degrees centigrade, initial temperature in degrees centigrade. So this will give me the initial temperature. Then I need the ambient temperature also, so E and V. Okay, so this one I want it's asking for the ambient temperature, the temperature of the surroundings, ambient temperature. And then there's something called the time constant. The time constant, okay, the time that it takes for the temperature to become 1 by E times its initial value. That is the time constant tau. So we will enter that time. Tau is also in seconds. So tau equals, oops, just reuse this code here. Tau equals, enter the time constant. Enter the time constant in seconds. Enter the time constant in seconds. Okay. So now I want to repeat this same thing. So what I have to do is I'll start at Ti, and then Ti I'll keep on adding. Ti for initial value, first value, initial value of time is Ti. Next value of time will be Ti plus delta T. Next value of time will be Ti plus twice delta T plus thrice delta T plus 4 delta T and so on. Okay, that is going to give me the entire thing. Let's just see if this works. Okay, so I'm going to use this while loop. I'm going to use this while loop to satisfy this condition. So I will define a variable I equals 0. This is the loop variable. Okay, so I is known as the loop variable. I is known as a loop variable. Let's just test it out first. So while I is less than n, okay, while I is less than n, let's just print I. Let's just print I, but then caution, before you do any kind of coding inside the loop, always have a way by which the condition ultimately it should get, it should be the condition should be violated. So you should have some way, because you see now if I don't do anything here, I is 0, I is always 0, I'm not changing I. So that means this condition I is definitely going to be less than n. So this condition will always be satisfied. So it will run into an infinite loop. So to prevent that, what I do is I plus equals 1. So then what is going to happen is, first I will take the value 0, then it will check, is 0 less than n? Yes, it is. It will go inside. Then I plus equals 1 means it will increase the value of I. I will now become 1. Now it will again check, is 1 less than this? Yes, it is still less. Again, it will go inside. It will keep on increasing the value of I. So let's say n is equal to 5. So until I becomes equal to 5, when I becomes equal to 5, then this condition will not be satisfied, and as a result, it will come outside the loop. So this is the loop termination. Okay, this is the loop termination. Okay, so this will ensure the loop termination. Otherwise, it's very dangerous to have an infinite loop. So now we can go about this. Let me just test out my things here. So print I, just see how things go. So it is asking me initial temperature 95, 35, 400. Okay, it is just giving me, see, I is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because what is n? N is number of divisions plus 1. So n is equal to 10 plus 1, 11. N is equal to, number of divisions is 10. So 10 plus 1 is 11. I starting value is 0. Then it adds, it becomes 1. It becomes 2, 3, 4, 5, 6. And n is equal to 11. When I becomes 10, 10 is less than 11, it will print. Next, what will happen is I will become equal to 11. 11 less than 11, not satisfied, it will come out and it will not print anything else. Okay, so what we have done is correct. The loop is going correctly. So now what I want to do is I want to calculate this. Okay, I want to calculate this. So the way to calculate is, first calculate the time. What is time? Time is initial time plus I into delta t. Initial time plus I into delta t. You can see for yourself. When I is equal to 0, when I is equal to 0, what is t? T is simply equal to ti, because I'm multiplying I with delta t. 0 into delta t is 0. So it will take the value initial time. Next, when I is equal to 1, when I is equal to 1, then what will be the value of time? It will be initial time plus 1 subdivision of time, 1 delta t. When I is 2, then it will become initial time plus 2 delta t. When I is equal to 3, it will become initial time plus 3 delta t, and so on. Okay, you could actually print this out also. Print t, some values. Okay, this is giving me the time instance, 0 all the way till 5000. So it's working perfectly fine. I have got the time now. Now next thing that I need to do is I need to calculate this. So I need to use this formula. So what we do is capital T. What is capital T? We use this formula. Capital T is the ambient temperature plus the initial temperature, okay, minus the ambient temperature, times exponent, right? So we can use this function we have already included here. We can just use this here. exp, okay, minus, we have t, we have calculated the time t here, divided by tau, whatever tau is given here. Okay, so now we can actually just go ahead and print this out. Okay, let's print out both of them. So we'll print out print t. Okay, and then we'll put a tab space here. It is known as the escape sequence. We'll see more of that later on. And capital T. Let's say if this works, initial temperature, let's keep it as 100 degrees centigrade. Ambient temperature, let's say room temperature, let's 23 degrees. Time constant, let's make it as 500. You see, initial temperature 100, then it becomes 51 at 500 seconds, 51, 1000 seconds, 33, 1500, 26. You see the temperature is gradually decreasing. Okay, it should tend towards 23, because 23 is the room temperature. Okay, it should tend towards, it should start from the initial temperature and it should tend towards the ambient temperature. So this is what should happen. So our function as program is working as we want, but this is not the way we want to display the output. Okay, we want it to look little bit better. We want to have some kind of a formatting here. So I could use the formatting strings again. So this one, the time period, I'll use 5 significant figures and 1 decimal place. So 5 significant figures means 6 point and 1 decimal place, F, and percentage. This will take care of this. Then I will use, let's say, two tab spaces. And then this one, the temperature, I will have, let's say, seven significant figures with three decimal places. Sorry, five significant figures with three decimal places. Five significant figures means 6 and three decimal places, 6.3 percentage F. Okay, now let's run this. 90, let's say, ambient temperature, let's say 26, 600. Okay, we are getting what we want. Okay, it looks much better. Now we just need some kind of way by which we can on top you can put, no, this is a table, right? All these things we can put. So we can actually do that. So we just need a print command outside. Before going into the loop, we just need a print command here just to make the table look good. So we will have something like T in seconds, then followed by 2 tab spaces, then temperature in degrees centigrade, okay, run this. 95, 26, 600, let's say we got this. Now it'll be better if we can put some kind of a line here. Just put some kind of a line here to segregate the first column. So we could put one more print, then just put a set of dashes here, maybe 3 more dashes. 1, 2, 95, 26, 800. Okay, now this is looking much better. You could put these set of dashes. You could put above now, and one set of dashes you can put after coming out of the loop. So this at the end it will just add the set of dashes. Now this is going to be complete. The table is going to be complete. 100 degrees centigrade, 26 degrees centigrade, and let's say 400. Okay, this is the table that we're looking for. So we have used a while loop. We use a while loop. Okay, the while loop, this is what it does. You have a loop variable. The loop variable is I. While this condition is satisfied, it executes these set of steps. After this is done, it executes this. It just prints out one single line. So this is your while loop. Okay. Now in a similar way, we can also have a for loop similar to a while loop. Okay, similar to a while loop, but it is more compact. Okay, this is the syntax. What I'm going to do is I'm going to just take the previous code. I'm just going to take the previous code and just copy and paste the previous code and just make the modification. Wherever there is a difference between this while loop and for loop, I'll just make the modification in the code. I'll show it to you how the same code, this time using a for loop. Just copy this here and paste it here. Okay, so but this time I'm going to use a for loop. How to use a for loop? We need to actually get the this loop variable. Okay, this loop variable, instead of being outside the block, we will just make it a part of the block. Okay, so this is how it's going to change. So what will happen is, till here it will just be just the same. So what we are doing is for, this is the loop variable. Okay, range n, that should do it. That's all. This is going to ensure that I will go take all the values which is returned by this function. This function, range function, we'll see that in detail. Whatever argument I give the argument n, so it will create a set of values starting from 0 till n minus 1. Okay, so 0, n is equal to 11. So from 0 to 10, it will create a set of values from 0 to 10. And then I will take the values. First, I will take the first value, then the second value, then the third, and so on. So I will keep on iterating for all the values that is created by this function called as range. Okay, so this is what it is. So you can see here in the for loop, you actually combined these two lines together. I equals 0 and I less than n, it is combined. And also this line. Okay, this is the incrementation. You're increasing I. So 3 lines in one single line. These two and this line, all 3 lines, these 3 lines are contained in one single line. Then after that, just copy these 3 lines and paste them here. We don't need this because this line itself will take care of that. And I'll just delete the rest of this. Okay, so this is what we have. Let's run this. 100 degrees centigrade, room temperature 26. Let's say this is 800, and we get the same output. Okay, this is using a for loop. This is using a while loop. Okay, any questions so far? Any questions? Let me just end with this range function. Then tomorrow we can talk about the user-defined functions. I think this is a good place to stop. The range function. Range function basically generates a set of integers that can be used to perform iterations. Okay, so range function is mainly used for performing iterations only. The syntax of the range is start, stop, and there's one more optional argument called as a step. And we have to remember that it only works with integers. Okay, and it is used in for loops. Okay, so suppose I keep something like this: for I in range, let's say 7, for I in range 7. Let's see what kind of values it generates. So print I, for I in range 7, print I. So if I just mention 7 here, that means the starting value, it will take the starting value by default, it will take it to be 0. Then till where will it go? It will go till 6. That means whatever argument I have given here, I have given 7, it will go just one integer before, only till here. So 7 will not be included. Okay, 7 will not be included in this. Okay. Then let's look at some other possibility. So same thing, I'll just copy this here. Now let us say I give a start value now. Okay, I give start value as 2. Okay, now you can see here, it will start from 2. So if you don't give any starting value, okay, if you don't give any starting value, it will take, by default, it will assume the starting to be 0. If you give a starting value, it will take that. So it starts from 2 and it ends with 6. Okay. Then I could also give something like this, the step size. So let us say 220. Let's do this first. So its starting value is 2. Starting value is 2 and ending value is 19. Let's say I want to include 2. Sorry. Now let's say I include this step. Okay, I put 3 here. Then what has happened is, first it takes 2. Then it steps of 3 it goes. 2 plus 3 is 5. 5 plus 3 is 8. Whatever is the third argument. Step by default, step is 1. Okay. Whatever is the third argument, that is what is going to be added to go to the next one. So step is 3 here. Okay. So 2 plus 3 is 8. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, 14 plus 3 is 17, 17 plus 3 is 20, but 20 is not included, so it will stop at 17. Okay, so that's the range function. Okay, now also one more thing that you can do here, you can also do one more thing. We could actually go the other way around also. So you could put 20 here and you could put 2 here and then you put minus 3. See what happens? It goes the other way around. It starts with 20. It starts with 20. Then 20 minus 3, 17. Minus 3, 14. Minus 3, 15. Minus 3, 11. Minus 3, 8. Minus 3, 5. Minus 3 will give you 2, but 2 is not included, so it will stop at 5. Okay. If you wanted to include 20, here, then make it 21. Then it will include 20. If you wanted to include 2 here, then make the stopping point, you make it as 1. Then 2 will also be included. So that's the range function. Okay, any questions? Any questions? You can move backward in this way. Okay, so suppose you're doing an iteration where you have to move backwards. You can use the range function in this way. If anybody has any questions, I can take that now. Else, I think we can stop.
I have a couple of questions.
Yes.
In if condition, or for that matter, for that for loop also, you are using indentations.
Yes, yes.
Generally, in C or Fortran, indentation is mostly for aesthetic purpose.
Yes, exactly.
Yes.
That's because
Yeah, but I think what I could get from your lecture here, it is a necessity because all the indented lines are taken as the part of that particular for loop or that particular if statement. Because in Fortran or C, they are separated by curly brackets, but here there is no such option.
Also, one
Am I,
more thing is, yes, yes.
am I
Also, because
correct?
like I said, no, is Python is a high-level language. It is high-level language means it is more closely. It is more closely more closer to the human, the language that we speak, the human language. It is more closer to the human language than to the machine language. So Python is a high-level language. So now also one more thing that you note in C, C++, every line must end with a semicolon. If you remember in C, C++, every line must be in a semicolon. So it really does not matter whether you indent or not. In C, C++, we could have a program which, you could put a semicolon, you could put semicolons, and you could have a program which runs only in one line. You could actually do that in C, C++. You can do that. But in Python, because there is no semicolon here, there's no way, there is no indicator for ending of the line. So whatever comes in one line, that itself is a line. So that's how you demarcate. And then for blocks, the use of curly brackets is gone. Instead of curly brackets, we use a colon. Okay, instead of having a curly bracket front and the curly bracket at the end, just one colon. After the colon, the next few lines must be indented. So that's how it identifies the blocks.
You mean the next few lines till the indentation goes back to the earlier
Yes, till then.
indentation?
Till the indentation, like for example here, right? This is
Okay.
the indentation, right? Then this is the indentation. The indentation must be same, okay? One more thing that we need to keep in mind is the indentation must be same. So for instance, let's say how many spaces? 1, 2, 3, 4. There are 4 spaces. Here also there are 4 spaces. Here also there are 4 spaces, and here also there are 4 spaces. Now let's say by mistake, I delete a space here. You see, it has become red. That means automatically it's telling me that there's a problem with the indentation. Okay. So let's say I
So,
just change this one. So if I run this, it will give me an error. You see, the indent does not match any outer indentation level.
so
So
here indentation
indentation,
is a necessity, not
yes,
because
it's a
not
necessity.
only because of aesthetic sense.
Not just essay, it's a necessity. It's a part of the syntax.
Okay.
Indentation is a part of the syntax. Now it's going to work.
Okay.
Any other questions?
One more small question.
Yeah.
In the
Yeah.
for loop, the increment can be fractional or not possible?
It can be fractional. In fact, I'm going to show that when only thing is the range function. The range function that we have that only works with integers. The range function only works with integers, but you could have fractional also. You could have fractional values also. There is something called as an array. There's a package called as NumPy. NumPy allows you to create arrays, and you can use those arrays values, and those arrays could have fractional values. So in fact, you can do something like this. Okay, for loop, you need not have to go like this. You could actually do something like this. Let me show you here. Okay, so you could have something like this. So for I in, I could have something like this. Let's say 0.1, 2.2, any value that I want, 3.9, minus 9.3, something like this. Okay, for this I could do print I. This will work just fine. It's just that it will go one after the other. 1.1, 2.2, 3.9 minus 9.3. It is going to print them out in that order. So here what we have used, this square brackets that I have used, this is known as a list. It is a type of data structure which is provided by Python. So this is a list. So we will do that in the next lecture. I'll be talking about data structures. So this is a list. List is a type of data structure. So you can use lists, and you can make this I. In the for loop, it works with lists also. It will iterate through all the values in this particular list. Okay, so it need not always be integers like this. It could be values like this. You could do something like this also. You could do something like this also. You could take the squares of this also, right? So this will also work. Print I square. That means 0.1 square. 0.1 square, it is going to print 0.01. Of course, there is a 2 because it is giving me a lot to a very high precision. Then 2.2 square, 4.84. 3.9 square, 15.20999, and so on. 15.21 minus 9.3. The square is this. So you could actually go around and you can work with this. So this will also work. So the for loop in this one in Python, it is very, very flexible.
Okay. Thank you.
Okay. Any other question? If there are no questions, then shall we stop for today?
I think we can.
Tomorrow, yeah, tomorrow what we'll do is, this is a good place actually, because tomorrow I will show how to use, how to create user-defined functions. Okay, this is actually, you can cut short a lot of your work. You can actually cut short using user-defined functions, and then we'll move on to data structures, which will lead us to visualization, analysis and visualization of data. Okay, we can stop, Samrat.
Yes, let's stop. Thank you very much, Parag. So let's meet tomorrow again. The links are given to the participants in their schedule. So please follow the link for tomorrow to join the Google Meet. Thank you.